Hello everyone, my name is Dr. Ch Apparao, working as an associate professor in mechanical engineering department. Today I would like to explain about the reciprocating machines. In last class we already discussed the types of lathes and what are the different operations performed on the lathe machine also, and we already discussed the central lathe and semi-automatic lathe and automatic lathes also we discussed. So before going to explanation about the reciprocating machines, now first of all we'll see the comparisons, the differentiations between the central lathe and semi-automatic lathes. Then we know that semi-automatic lathes are two types, mainly capstan and turret lathes, and we'll see the differences and classification differences between the capstan lathe and turret lathe also. Okay, so before going to that, just we will see the outcome which is related to this topic. So at the end of this course, students should be able to explain the operational principles of different lathe machines and various reciprocating machines. You know that these are the lathe machines, reciprocating machines also. Just in this class we'll see the we'll discuss about the reciprocating machines for the quality machining. Okay, we'll see the difference between the central lathe and semi-automatic lathes. So central lathe is completely manual lathe and it is operated manually. This one is the capstan and turret lathes are semi-automatic lathes. We'll see the manual lathe and the difference between the manual lathe and the semi-automatic lathe. Okay, so here some points are given. Just we'll see. We know that the central lathe, which is a very common lathe, which is used in just like in our workshops and different industries. Okay, we'll see. Capstan and turret lathe is semi-automatic lathes, mainly used for the mass production. Okay. We'll see the some differences between the central lathe and capstan and turret lathe. Okay, so central lathe is a manually operated lathe, so completely operated by operated by operator. Okay. So manual operation should be needed here for the functioning of any operation on this central lathe. Okay, so but in case of turret or capstan lathes, so it is a semi-automatic lathe. So some operations like fitting of the tools and just like setting up the workpieces. Okay, so for these things are done manually, but setting up the tools and performing the operations based upon the requirement, so those things are done automatically. Okay, so central lathe is the manually operated lathe and the capstan turret lathe are the semi-automatic lathe. So it has only one tool. You know that in central lathe only one tool post is there, and we can fix that one tool bit and one tool, single point cutting tool, we can fix on that tool post. Okay, so it is only one tool post, and the tool changing time is very more. So if you want to change the tool, just you have to remove the previous one and you can set another tool bit. Okay, so changing of the tool that takes more time here in central lathe. So but in case of capstan and turret lathe, you know that this is the guide ways in front portion and the front to just like in the front portion we have some two types of the four types of the tools, one tool bit, another tool bit, another tool bit here also. In rear portion also, here also we have some tool posts, so we can fix here two types of the tools. Okay, so number of tools can be fitted on this lathe machine. So you know that turret head has 6 faces, and each face we can fit the different types of the tools. So totally 6 tools and two. So total 10 tool bits can be fixed on a single time. So front and rear tool posts are available. Tool changing time also very less. So when functioning is going on, we can change the tool bit also here. Okay. So the operation is going on by the turret head. So the tool which is fixed in the turret head. So at that time we can change the tool bits, required tool bits in front and rear tool post. Okay. So this type of accommodation will be available on this turret capstan and turret head. So the tool changing time is very less here, but here very high. So next one is the we know that central lathe has tile stock. Okay, your head stock left side and right side tile stock is there. Tile stock so helps to support the workpiece, or sometimes by the help of the or we can fix the different tool bits in the tile stock to perform operations also. So central lathe has tile stock. Okay, but in case of capstan and turret lathe, so we will see the turret head instead of tile stock. So this is the guideways, and left side head stock, and right side tile stock. You know that. So this type of arrangement is provided on the lathe machine. But in case of turret head, capstan and turret lathe machine, we will see turret head, 6 faces turret head here. On each face there is a accommodation to fit the different tools. Okay. So on each face we can fix 6 tool bits. It means on each face we can fix each one tool bit, and it means this 6 turret head. It means the turret head has 6 tools. Okay. Okay. So this one is the so it has central lathe machine has tail stock. In case of turret head, so tile stock is replaced by, instead of the tile stock, okay, we'll fix the turret head. So that is the main difference between the central lathe and capstan lathe. So only one tool can be fitted in the tile stock. We know that there is only one accommodation is there in tile stock. So here we can fix the tool bit which is required for the operation, required operation. So one tool can be fitted in the tile stock, but here you know that 6 turret head has 6 faces, and each face we can fix each uh, tool bit. Okay, so it means 6 different tools can be fitted in the turret head here. So that is the type of accommodation is provided and the capstan turret head. Next one, number of speeds is less. Okay, so hardly 2 to 3 types of speeds can be maintained on the central lathe, but the number of speeds is more in case of the capstan and turret lathe. You can maintain different types of these speeds also. So here tool changing time is very high, very more. Okay, if you want to change the tool, just you have to stop the operation and remove the tool bit, and we have to fix the another tool bit. So that takes more time. But in case of lathe machine, capstan and turret lathe machine, tool changing time is very less. Okay. The machine should be stopped while changing the tool in central lathe machine. If you want to change the tool bit, you have to stop the machining operation. You have to stop the machine. But in case of capstan turret lathe, tool can be changed without stopping the machining. So that is the the features of semi-automatic lathe machines. So now few more differences also here we can observe. It is not suitable for the mass production. So mass production, when you know that mass production means the same type of product can be produced in a lot more size. Okay, so it is not suitable for the mass production because for every operation you have to change the tool bit and have to change the we have to stop the machine and to change the tool bits. So, but capstan and turret lathe is suitable for the mass production because according to the sequence of the operation, we will fix the tool bits in front and rear tool post and hexagonal head. As per the requirement, we fix the we uh, position the tool bits, tool post, required tool post, required tool bit, and to perform the operations, sequential operations can be performed here. So that is the main advantage of capstan turret lathe. Next, no feed stops to control the tool bit. There is no type of any feed stops to control the just a tool. But here tools are controlled by feed stops also. Okay. Here next, a tool is centered manually. So positioning of the tool is done manually here for changing of the tool. But tool is centered automatically by just indexing process. Just if you rotate that one automatically, next face or next tool which is mounted on the another face of the turret head that comes into positioning to perform the operation. So here only one operation is done at a single time, at a time. Okay. See here we can perform the different operations in a same time. Okay. So by using the turret head and by using the front and the rear tool post. So these are the just like differences between the central lathe and the capstan turret lathe. Okay. So now we'll see capstan lathe and turret lathe. So both are semi-automatic lathe, but there is a small differences between the capstan lathe and turret lathe. Okay. So you know that. So capstan lathe and turret lathe. So capstan lathe is very lightweight machine. Okay. So but turret lathe is the very heavy weight machine. So if you want to perform heavy weighted jobs, you can prefer the turret lathe machine. But in both cases, in two machines, we have the turret head. Okay. But in capstan lathe, the turret head is mounted over the ram. Okay, ram moment. So on the ram, the turret head is mounted on the ram. Okay. So by moving the ram, we can perform the just we can move the turret head and we can position the tools which are positioned, which are fixed in the just like turret head. Okay. But the ram movement is just like is limited. Okay. So you can see in the capstan lathe, the turret head is mounted over the ram, that is mounted over the saddle. Okay. So in the on the guideway, saddle is there. On the saddle, ram is fixed. So ram movement is very less. Okay. But in case of turret head, turret head, so okay, so turret tool, the turret tool or turret head is mounted over the saddle directly. So on the guideways, the saddle is positioned on the saddle. This type of the turret head is just mounted on the saddle. So the saddle moves on the guideways. So as uh, as for the required distance. So it means so in the capstan lathe, movement of turret head is limited because the ram movement is limited. So it moves up to certain distance. But in case of turret head, the turret head is mounted on the saddle. The saddle can move from one side of the guide west to another side of the guide west. It means the saddle moves between the from left to headstock. Okay, so it means turret head movement in capstan lathe is limited, but in case of turret head movement in turret lathe is maximum. Okay, so for providing the feed to the tool, ram is moved. Okay, just like for the feed of the tool, just like we will use the ram movement for providing the feed to the tool, we will use the saddle. Okay, because this turret head is directly mounted on this saddle. Okay. So because of no saddle displacement, movement of turret head is over the longitudinal direction is small. That is very important. Small along with the ram. But in case of turret head, okay, it moves along the saddle over the entire bed in the longitudinal direction. So the movement of the turret head in capstan lathe is limited because the turret head is mounted on the ram. So ram movement is limited. But in case of turret lathe, the turret head movement is very high because it is mounted on the saddle. The saddle can move the entire bed. Okay, so these are the differences. Okay, next to capstan lathe. So capstan lathe, a very lightweight lathe machine compared to turret lathe machine. So it is used for the shorter workpieces because of limited ram movement, shorter workpieces. But in case of turret head, used for the longer workpieces, the heavy workpieces can be performed on the turret lathe machine because the saddle movement along the bed is very high. Okay. Heavy cuts on the workpiece can be given because of non-rigid construction here. Heavy cuts on the workpiece can be given because of the rigid construction. Okay. So here non-rigid, so rigid. So rigid means very fixed properly. So that is the main advantage of the turret. Okay. So few more differences given here. For indexing turret tool head, indexing means position of next tool into the against the workpiece. Okay, the hand wheel. So indexing turret head is operated by the hand wheel of the ram. Okay, so but in case of turret lathe machine, this indexing turret tool head. So the turret is rotated manually after releasing the clamping lever. Turret head cannot be moved in the lateral direction of the bed, but here the turret head can be moved crosswise also. Okay. So because it is mounted on the ram moves longitudinal direction. So in case of central lathe, turret moves only longitudinal direction. But in case of turret lathe, so the turret is mounted on the saddle. The saddle by the help of the cross slide, we can move the turret head in crosswise movement also. Okay. So in capstan lathe, collets are used to grip the workpieces, grip the jobs. But in case of turret lathes, power jaws are used to grip the jobs or workpieces. So capstan lathe used for the machining workpiece up to certain limited diameter, that is 60 mm. But in case of a turret lathe machine, so it is 120 diameter, up to 120 diameter we can perform the operations. So these are usually horizontal lathe machines. Capstan lathe machines means horizontal lathe machines, but turret lathe machines either horizontal or vertical. So two types of lathe machines are available in the market. So these are the just differences between the semi-automatic lathes. One is capstan lathe. This is not central capstan lathe and turret lathe. Okay. So these are the differences. Now we will discuss about the reciprocating machines. There are different types of the reciprocating machines. So in this class we will see the shaping machine. So the shaping machine is used to machine the flat surfaces mainly. Okay. Lathe machine used to perform the cylindrical surfaces or cylindrical objects or turning operations. But shaping machine, so that is used for the machining the flat surfaces, flat surfacing, just rectangular surfaces or square type surfaces. Okay, so especially here the main advantage of the shaping machine is depth of cut is very high, material removal rate is very high in each stroke. Okay. So large number of metal can be removed here. Okay. So other machines like milling machines, just like are much more expensive and more suitable to remove small amount of the material. So material removal rate in milling machine is very less compared to shaping machine. Milling machine is very expensive and shaping machine is the very cheapest cost. So for the just like for removal of any slots are high required, if we required uh, high removal of the material, we can prefer the shaping machine also. Okay, the shaping machine is simple at extremely effective machine. Okay, so it is very simple construction, but removal rate, material removal rate is very high by shaping machine. So it is used to remove the material, usually metals, mainly for the metals such as steels, aluminum. Okay, to produce the some grooves or some flat surfaces. Okay, so it can also be used to manufacturing some gears, gear manufacturing, rack manufacturing. So for this one we prefer the shaping machines. This is the block diagram of a shaping machine. You know that this is the base. It is made by cast iron. We know this one. Cast iron is the very brittle, hard material, so it can withstand all the vibrations which are occurred in the machining process. Okay, so this is the base. So on the base, remaining parts are accommodated or position fixed on the base. So this is the hollow rectangular column. Just inside the this column, we will see the just like lubricating system, oiling system, and uh, mechanisms which are used to convert the rotating motion into reciprocating motion. So you know that in lathe machine workpiece will rotates. So that is the rotational motion. So motor also rotates. The same rotating motion is converted to workpiece. But here motor rotates. That rotating motion is converted into reciprocating motion. Reciprocating motion means to and fro motions. Okay, so you can see. So there is a mechanism which is used to convert the rotating motion of the engines into reciprocating motion. So we'll see what are the different types of mechanisms which are used to convert the rotary motion into reciprocating motion. So there are 4 types. We'll see. Okay, so this one is the table. So this is the just like support. In the front face of this column there is a guideways. So by using this supporting key and the guideways, the table moves in upward and downward direction. Okay, so on this table, just like we can there is a vice is there to hold the workpiece. We can fix the workpieces hold. Okay. So this is the just like in this way, just we can move the uh, by the help of this one. There is a shadow. So we have the upward direction movement and cross movement also provided, and slide movement also there. So by the help of these vices. Okay, uh, at the front portion of this ram, so front portion of this ram, there is a tool head. uh, so and just like a tool head has the tool post, in the by the help of the tool post we can fix the single point cutting tool. Okay. So here just like this one, single point cutting tool, the swiveling tool post is there. We can tilt the direction positioning of the tool post also here. Okay, so the rotary motion is converted into reciprocating motion. The ram moves in forward and backward directions. Forward is nothing but a cutting stroke. Backward is nothing but just like a relief stroke. So the both the strokes, uh, just forward and backward, that is called just like one stroke. So forward motion and backward motion, the complete the sum of forward and backward, that is called stroke. The stroke of motion means forward and backward. Okay. So in this way, just like the material will be removed on the workpiece. So the material removal rate is very high. So by using this one, you can produce the flat surfaces or some gearings also. Now we'll see different parts of this shaping machine. You know that bed base made up of cast iron by casting process. Okay, so you know that cast iron is very hard and brittle material that can withstand all type of vibrations. Okay, on this base there is a column, rectangular hollow type column. Inside the column there is a mechanisms which are used to conversion of the rotor motion to reciprocating motion, and some lubricating systems also provided in the hollow space. So in the front portion there are some guideways, and top portion also guideways, and the top portion ram will move. In the front portion the table will move in upward and downward direction. So here, so this one, these are the guideways, these are the guideways. These guideways are used to move the ram. These guideways are used to move the table to accommodate the workpiece in front of uh, tool post. So there is a just like table sliding support here. So by using this support and guideways which are provided in the column, the table will move in upward and downward direction. With the help of this key, we can, so that is called elevating handle. By this elevating handle, you can move upward and downward direction. Okay. So on this one, just like there is a vise which is fixed on the table by some slots and uh, nut and bolts. Okay, so you know that vices, one is fixed, one jaw is fixed, and another jaw is movable. By the help of the movable jaw, we can fix the workpiece in the two jaws. Okay, so this is the just like holding up the workpiece. In case of lathe, you know that there are some vices, bench vices, forger checks are there. Okay, here vices are there. Okay. So you have to observe the comparison between the lathe and the shaping machine. Okay, so in the front portion of the ram, so the ram moves on the front and back, through and fro motion by the help of the guideways which are provided in the column. Okay. So here front portion there is a tool head. So in the tool head there is a tool post is there to fix the just like tool bit. Okay. So there is a ram clamp to fix the movement of the ram also. So tool head and the vertical slide, so it moves on vertical sliding also. So the swiveling just by the help of the inclination we can tilt the workpiece also, tool bit also. So we can perform the angular surface machining also here. So these are the just like different parts of the lathe machine. So this is the feeding, tool feed handling. By the help of that one, will give the feed of tool bit to cut the to remove the material from the workpiece. So this is the just like mechanism of shaping shaper machine. So here you know this is the that is the engine that will rotates. Okay, this rotary motion is converted into reciprocating motion by the lever and just like hollow type lever and clamp. Okay, so it has two jaws. One is attached to the ram, another is fixed with the pinion. so which is mounted on the just like this gear. Okay, so by just like this is the rotary motion is converted into reciprocating motion by the help of this slot and pinion type. Okay, so in this way, just like in forward motion, material will be removed. So reverse motion, so that is the free motion. So forward and backward, that is called one stroke. Okay. And this way, just like shaping material will be machining will be performed by the shaping machine. Okay. So this is the just like mechanism which is used to convert the rotary motion to reciprocating motion. Okay. So this is the driving gear which is connected to the motor. So through driving gear, the power is transmitted to the crankshaft. So on this crank there is a pin is pin. This pin is just slides in the this is called just like slot, rectangular slot. Okay. So this mechanism we can observe when the driving gear is rotates, automatically crank will rotate. When the crank will rotate, the pinion moves in the slot up and move. So when they are moving, just like oscillating system, that pin moves on upward and downward direction. Automatically, ram moves in forward and backward. So in this way, so the rotary motion is converted into reciprocating motion. So this is the one of the mechanism to convert the rotary motion into reciprocating motion. Okay, so there are four types of mechanisms are there to convert the rotary motion into reciprocating motion. One is the crank and slotted link mechanism. Okay, so what was already saw that one. So next, Whitworth Quick's mechanism also there. We'll see later. Next, hydraulic shaper mechanism also available. Next, automatic table speed mechanism also available. So there are four mechanisms are used to convert the rotary motion to reciprocating motion. So simply these type of machines are called reciprocating machine because the tool is moves in forward and backward, so to and fro. So in the reciprocating motion. So here, just like one stroke means that is the cutting stroke and return stroke. So forward stroke is the cutting stroke. In the forward stroke, material will be removed. That is called simply cutting stroke. Return stroke is the free movement, just comes freely. That is called return stroke. The cutting stroke and return stroke, it is called completely one stroke. So this is the working principle of the shaper machine. So here, just like we can perform the vertical surface machining also. This is by swiveling mechanism. We can tilt the just like cutting tool, and you can perform vertical machining also. Okay. So just like inclined surface also you can perform. Okay. Angular surface facing, and just by swiveling arrangement, by the help of swiveling arrangement, we can fix the certain angle and we can perform the operations. This type of groove also you can angular surfaces can be performed. Okay. So here you can see types. The tool post has been turned at a angle so that the side of the material can be removed, just like. So this is moves forward and backward motion. We will get the flat surfaces. Here, just like the top slide, you slowly feed into the material. So we will get the rack positioning. So we can make the racks, and we can perform the gearing systems also. We can perform some grooves also. So by using the shaping machine, we can perform different operations. So these are the just like the uses and the working principle of the under different parts of the shaping machine. Okay. So in next class we'll see what are the different operations can be performed in the lathe machine, in shaping machine. Thank you for listening to this.
Like, share and subscribe. Hit the bell icon for more updates.